Hello, this is Mahmoud Mustafa Al Maruf. Today I am presenting my mid project of CSE489, the Smart Geo-Tagged Landmarks application. I designed this app with an offline first architecture, ensuring it works flawlessly even when the internet disconnects. Let's look at the UI first. Here on the map screen, I use Flutter map with OpenStreetMap. If you look at the markers, they have dynamic color coding. Green pens show high landmark scores, orange marks average ones, and red indicates poor scores. When I tap a marker, it pulls up the landmarks image and score from the server. Now I will click visit landmark. As soon as I clicked visit, the app triggered the phone's GPS sensor to check my location. Because I am using an emulator, I wrote a validation fallback to ensure the distance sent is always valid. Next, let's go to the landmarks list. This list automatically sorts the highest scoring places at the very top. Notice what happens when I sweep left. The item disappears instantly. This is called an optimistic UI update. It makes the app feel incredibly fast for the user, while the actual API deletion happens silently in the background. Now on the activity screen, you can see a complete history of the places I visited, and this entire screen is uh, loaded from a local SQLite database, meaning my history is safe even offline. Finally, the add landmark screen. If I click face current GPS, the geolocator package attempts to get my device location. I added a custom 5-second timeout here. Emulators often struggle with GPS, so this timeout ensures the app never freezes or crashes when waiting for a sensor payload. I can also pick images from the gallery or camera to upload right from here. Now I will show you the code that makes all of this work. The app is structured into models, screens, providers, and services. Starting with the main.dart, I wrap the entire application in a multi-provider. This injects our landmark provider into the widget tree, which means any screen can update or listen to data in real time. In the model folder, I created three Dart classes. The most unique one is pending requests. It uses serialization. If the device loses internet, any action the user takes, like visiting or adding a place, is serialized into a string using this model and saved natively on the device. To upload landmarks, I build a API service. This handles standard JSON REST calls. However, for adding a new landmark, a standard JSON does not work because we are uploading an image file. Look at the create landmark function. I implemented HTTP multipart request, and this takes the local image byte stream, attaches the location data, and submits it exactly like a web browser's form upload, satisfying the university's backend requirements. To store data locally, I build a device service. I use a singleton pattern here to ensure SQLite only opens one connection at a time. Through the on create method, I generate three tables: one to cache map markers, one for visit history, and a very special pending request queue. This brings us to the core of the app, the landmark provider. I want to draw your attention to my background sync worker, which is the check pending queue function. Every time the app launches or the user refreshes, this function checks the SQLite queue. If there are requests that failed previously, it attempts to resend them to the backend API. It only clears the local queue if it receives an HTTP 200 success code. Because of this single function, no user data will ever be lost due to network issues. In summary, I built an app that prioritizes stability by combining the reactive nature of the provider, architecture with the robustness of SQLite caching, and this app successfully handles geolocation, multipart image uploads, and offline data synchronization gracefully. Thank you.